When we started Chapter 3, we looked at solving a system of equations with substitution or elimination. What we're going to learn today is a method called Cramer's rule. Cramer's rule is now a third method that we can use to solve a 2x2 system of equations. First thing you want to make sure is that you have your system set up where your x and your y terms are on the same side, left-hand side, set equal to a particular number on the right-hand side. You want to make sure that they are both set up that way. Ax plus by equals e, cx plus dy equals f. So those will be your two equations. First thing you have to be able to do is identify some matrices. The first matrix will be called the A matrix. A matrix will be made up of the constant values in front of your x's and your y's. So we need to pull out these four values, A, B, C, D, and we're going to put those in here and we're going to call it the A matrix. The B matrix is made up of these two answer guys right here. So this B matrix will look like this. It's going to be a 2x1 matrix. Your A matrix is a 2x2 matrix. After we get our A matrix done, the first thing you want to do is find the determinant of that A matrix. Now remember we talked about determinants. Multiply down the diagonal, A times D, minus, multiply up the diagonal, C times B. This is going to give you a one-number answer. We're going to use that number twice. We're going to use that when we solve for x. That value will be down here in the denominator of our fraction. And we will also use that same number when we solve for y. It's going to be down here in the denominator when we solve for y. Now, how do we get the answer for our x? What we're going to be doing is a little cut and paste. What you need to do is, I'm going to erase some stuff here. To solve for x, what we're going to do is a cut and paste. We're going to cut out the x numbers from our A matrix, the A and the C. We're going to cut out the x numbers and we're going to replace them with the B values, E and F. Those are going to go in place of that. So to solve for x, cut out the x numbers, replace them with the E and the F, but leave the B and the D where they are. And we need to find the determinant of that new matrix. Once we get that determinant, we're going to divide by the regular determinant that we got from the very beginning. I told you we needed to find the determinant for A. That value will be on the bottom. Now, when we solve for y, we're going to do the exact same thing, except instead of doing a cut and paste with the x terms, we're going to do a cut and paste with the y terms. Cut out the b, d values in front of those y terms and replace those b, d values with your B matrix answers of E and F. It would look like this, A, E, C, F. And then we will find the determinant of that new matrix and divide by the determinant of the original matrix. So this is all about doing a little cut and paste, substitute in two numbers for two original numbers. That's going to help us, and we'll be able to get our two answers for x and y. Let's try it. First one, 6x minus 2y equals negative 16, negative 3x plus 5y equals 16. First thing we need to do is identify our two matrices. A matrix is the values in front of your x's and y's. 6, negative 2, negative 3, 5. Your B matrix is the answer numbers. Negative 16, positive 16. The determinant of the original is 30 minus 6. Determinant of the original is 24. So when I solve for x, I will divide by 24. When I solve for y, I will divide by 24. Now, how do I get the top of my x number? I need to do a new determinant. I take out my original x's, which would be the 6, negative 3 values. I'm going to take those out, and I'm going to replace them with negative 16 and positive 16. The other two numbers stay intact, negative 2, 5. Now I do my determinant. Negative 16 times 5, negative 80, minus 16 times negative 2 is negative 32. There's a plus plus. This whole thing will divide by 24. Negative 80 plus 32 negative 48, divide by 24, negative 2. My x answer, negative 2. Now I do the same thing for my y value. I need to find a new determinant. This time, instead of cutting out the x numbers, our x numbers were 6, negative 3. Now I'm going to cut out the y numbers. When I solve for y, I cut out the y, and I replace them with my b values of negative 16 and positive 16. And now I do my determinant. 6 times 16, 96, minus negative 3 times negative 16, 48. Whole thing divides by 24. 96 minus 48 is 24 over 24, 1. My y value has an answer of 1. So this original system has an ordered pair answer of negative 2, 1. You now have another way that you can solve a system of equations. Whoops, I have a mistake down here, sorry. This is not 24, this is 48, and 48 over 24, 2. I got ahead of myself there. That's a 2. That's a 2. So your solution should be negative 2, comma, 2. All right, let's try that one again. Negative x plus 2y equals 5. 2x minus 2y equals negative 4. Your A matrix. Pull out the numbers in front of your original x's and y's. Negative 1, 2, 2, negative 2. Your B matrix is the answer solutions of 5, negative 4. I need the determinant of my original A matrix. 2 minus 4, negative 2. When I solve for x, I'll divide by negative 2. When I solve for y, I'll divide by negative 2. Your new x matrix. Determinant of, cut out your x numbers, replace them with 5, negative 4. The 2, negative 2 stay intact. Negative 10 minus negative 8 over negative 2. There's a plus plus. Negative 2 over negative 2. X answer is 1. Y value, the new determinant of. Now we're going to cut out the y term. I'll just use a different color. We're going to cut out the two y terms, and we're going to replace the y terms with the 5, negative 4. The original first x numbers stay intact, negative 1, 2. And now I do the determinant. 4 minus 10, negative 6 over negative 2. My y value should be 3. So the solution to this system is the ordered pair 1, 3. I kind of like this system. It goes quickly. You don't have to worry about substitution. It's just another method now that we can use instead of either substitution or elimination. All right, we're going to start one 3x3 system, and we're going to solve for x. You guys are going to have to try to solve for y and z by yourself, and we're going to check tomorrow and see if you could come up with the correct answer. All right, so we have to identify the A matrix, all of the numbers in front of your x, y's, and z's. Negative 1, 1, 1, 4, negative 1, 4, 1, 2, negative 1. Your B matrix, the answers, negative 3, negative 14, 9. Now we have to find the determinant of the original. This is a 3x3. So now we have to remember the process on finding the determinant of a 3x3. This takes a long time, which is why we're only going to solve for x. Determinant. Negative 1, 1, 1, 4, negative 1, 4, 1, 2, negative 1. Do you remember this? Put in your dotted line. Repeat the first two columns. Negative 1, 1, 4, negative 1, 1, 2. Now we're going to go down, down, down. Subtract the up, up, ups. Negative 1 times negative 1 times negative 1. Negative 1. Plus 1 times 4 times 1. Plus 1 times 4 times 2. 8. Those are the down values. Negative 1 plus 4 plus 8 should be 11. Now, when we do determinants, remember we subtract in between. So now I have to go up the diagonal starting in the bottom corner. 1 times negative 1 times 1 plus 2 times 4 times negative 1 plus negative 1 times 4 times 1. Negative 1 plus negative 8 plus negative 4, negative 13. I have 11 minus negative 13 is a plus 24. The determinant of my original is 24. Now when I solve for x, I have to find a new determinant, and remember this whole thing will divide by 24. How did we get our x value? We cut out each of the original x numbers, replace them with the answer values of negative 3, negative 14, 9, and then keep the other numbers the same. 1, 1, negative 1, 4, 2, negative 1. Now here again, we've got another 3 by 3. Okay, I'm going to erase all of this. We've got our value that we're going to divide by is 4 right here. So I'm going to erase all of this just to give myself some room here. Now remember, with our determinant, I have to repeat the first two columns. Negative 3, 1, negative 14, negative 1, 9, 2. Down, down, down. Negative 3 times negative 1 times negative 1. Negative 3 plus 1 times 4 times 9 plus 1 times negative 14 times 2. Subtract. Now we'll work our way up the line. 9 times negative 1 times 1. 2 times 4 times negative 3. There's 8 times negative 3, negative 24. Negative 1 times negative 14 times 1 plus 14. Negative 3 plus 36 minus 28 should be 5. Subtract. Negative 9 minus 24 plus 14 should be a negative 19. Minus minus is plus plus 24. So the top of my x value is 24. My original determinant was 24. My x value is 1. So this system, this 3 by 3 system, is going to be an ordered triple, not an ordered pair, x, y. It's an ordered triple, x, y, z. We got an x answer of 1. I want you guys to try to do y and z by yourself. See if you can come up with the correct answers for y and z. All right, so that's it for this particular section, the second half of 3.7, using Cramer's rule to solve a system of equations.